Hello everyone, this is Rajamanikam from QPT. Researchers create a curious machine learning model that finds a wider variety of prompts for training a chatbot to avoid hateful or harmful output. A user could ask ChatGPT to write a computer program or summarize an article, and the AI chatbot would likely be able to generate useful code or write a cogent synopsis. However, someone could also ask for instructions to build a bomb, and the chatbot might be able to provide those too. To prevent this and other safety issues, companies that build large language models typically safeguard them using a process called the red teaming. Teams of human testers write prompts aimed at triggering unsafe or toxic text from the model being tested. These prompts are used to teach the chatbot to avoid such responses. But this only works effectively if engineers know which toxic prompts to use. If human testers miss some prompts, which is likely given the number of possibilities, a chatbot regarded as safe might still be capable of generating unsafe answers. Researchers from Improbable AI Lab at MIT and the MIT IBM Watson AI Lab used machine learning to improve red teaming. They developed a technique to train a red team large language model to automatically generate diverse prompts that trigger a wider range of undesirable responses from the chatbot being tested. They do this by teaching the red team model to be curious when it writes prompts and to focus on novel prompts that evoke toxic responses from the target model. The technique outperformed human testers and other machine learning approaches by generating more distinct prompts that elicited increasingly toxic responses. Not only does their method significantly improve the coverage of inputs being tested compared to other automated methods, but it can also draw toxic responses from a chatbot that had safeguards built into it by human experts. Large language models like those that power AI chatbots are often trained by showing them enormous amounts of text from billions of public websites. So, not only can they learn to generate toxic words or describe illegal activities, the models could also leak personal information they may have picked up. The tedious and costly nature of human red teaming, which is often ineffective at generating a wide enough variety of prompts to fully safeguard a model, has encouraged researchers to automate the process using machine learning. Such techniques often train a red team model using reinforcement learning. This trial and error process rewards the red team model for generating prompts that trigger toxic responses from the chatbot being tested. But due to the way reinforcement learning works, the red team model will often keep generating a few similar prompts that are highly toxic to maximize its reward. For the reinforcement learning approach, the MIT researchers utilized a technique called curiosity-driven exploration. The red team model is incentivized to be curious about the consequences of each prompt it generates, so it will try prompts with different words, sentence patterns, or meanings. During its training process, the red team model generates a prompt and interacts with the chatbot. The chatbot responds, and a safety classifier rates the toxicity of its response, rewarding the red team model based on that rating. The red team model's objective is to maximize its reward by eliciting an even more toxic response with a novel prompt. The researchers enable curiosity in the red team model by modifying the reward signal in the reinforcement learning setup. First, in addition to maximizing toxicity, they include an entropy bonus that encourages the red team model to be more random as it explores different prompts. Second, to make the agent curious, they include two novelty rewards. One rewards the model based on the similarity of the words in its prompts, and the other rewards the model based on semantic similarity. Less similarity yields a higher reward. To prevent the red team model from generating random nonsensical text, which can trick the classifier into awarding a high toxicity score, the researchers also added a naturalistic language bonus to the training objective. With these additions in place, the researchers compared the toxicity and the diversity of responses their red team model generated with other automated techniques. Their model outperformed the baselines on both metrics. They also used their red team model to test a chatbot that had been fine-tuned with human feedback so it would not give toxic replies. Their curiosity-driven approach was able to quickly produce 196 prompts that elicited toxic responses from this safe chatbot. In the future, the researchers want to enable the red team model to generate prompts about a wider variety of topics. They also want to explore the use of a large language model as the toxicity classifier. In this way, a user could train the toxicity classifier using a company policy document, for instance. So a ready model could test a chatbot for company policy violations. Thanks for watching this video. Now you can get my ebooks with a huge discount at rajamanikam.com by using the discount code QPT. Contact me if you are interested in earning a 50% commission for selling my ebooks and course. Thanks.